These are notes from Melham's Math 60 for Tuesday, April the 28th, section 9.5, page 810. Today we're doing base e to the x, and the corresponding log, which is called the natural log. So on a basic calculator, you're looking for ln, and right above it, usually the second function is e to the x. So e is a funny number. The approximate value of e is 2.71828. You don't have to memorize that. Okay, and if you want to see the number e on your calculator, if you have an e button, you can just hit the e button. If you don't have an e button, you can trick it by raising e to the first power. So I'm going to try that on my calculator right here, the second function e to the x, and raise it to the first power. So e to the first power, and it comes out to be something like 2.71828. If you can't see it there, that's okay. I've got it here. So e is roughly 2.71828. It's the base for something called natural logs. So we have something called ln. ln stands for natural log or log natural. So on your calculator, you have two kinds of logs. The log is base 10. The ln stands for natural log or log natural. The base is e. And if you ever forget it, you just peek right up here. So for the log, if you forget what the base is, just look above, it's base 10. And for the ln, if you ever forget what the base is, just look above, the base is e, where e is this funny number 2.71828. Okay, problem 25, it just asks for the graph of e to the x. So I plug in -2, -1, 0, 1, and 2. So in each case, you're just doing e to that particular number. On my calculator, I would hit second function, e to the x, and then type whatever the number is. Remember, on some calculators, you have to go backwards. So some of you, on your calculator, you have to hit, let's say, if you want e squared, you have to hit the 2 first, and then second function e to the x. And likewise for all the other ones, for -2, you would have to hit -2 first, and then hit e to the x. Quick reminder, to get the negative on my calculator, there's a button down here that puts the negative. Don't use this button. This button's for subtraction. This button with the parentheses and a minus, that's to make a negative number. On some calculators, there's a plus or minus button. It looks like a plus and a minus. That's how you would get a negative. So just experiment. If you're not sure, send me an email and I can try to help you out. So anyway, we've plugged these in the calculator and plot it, and the graph looks like this, which is typical of exponential functions. So again, notice when I make my graph, I hardly leave any space at all for negative y's because there aren't any points that are down there. 0, 1, 1, 2.7, it's almost 3. 2 is 7.4, almost 7.5, so I go up to about 8. And these numbers are very, very small. They go right up against the x-axis. We've seen stuff like that before. 29, the only difference is it says e to the x plus 3. So because of that, notice the 5 numbers I picked are the same as these numbers, except I subtracted 3. So here it goes -2, -1, 0, 1, 2. If I subtract 3 from all of these, I get -5, -4, -3, -2, and -1. The reason why I want to do that is because before I do the e function, I have to add 3 anyway. So when I add 3, -5 plus 3 is -2. I'm doing e to the -2. But then I realize, hey, I already did that over here. Likewise, if I plug in -4 plus 3 is -1. And I get 0.37, and so the numbers will all match. And what's going to happen is this graph essentially just gets shifted over 3 units to the left. So -5 to -1. Notice I don't have any points here in quadrant 1. It looks like all the points are in quadrant 2 that I'm picking. Even though this graph eventually shoots up over in quadrant 1, but this is all that we care about right now. So I plug in all the points, and the graph looks something like that. Problem 33, they give you something called a compound interest formula for continuous compounding. A equals P e to the RT. You don't have to memorize that formula, but A stands for new amount, P is principal, E is the 2.718 thing, R is interest rate, and T is time. So this is something called continuous compounding. You don't have to memorize that, but just plug everything in. So they're saying, what's the new amount if you invest $5,000 at 8% for 20 years under something called continuous compounding? So I just plug everything in. A is 5,000, E raised to the 8% is 0.08 times 20, punch it in the machine, and remember to get E to something, you have to use this button, ln, and above it is e to the x, so you have to hit the second function to hit that. And this is money, it comes out to be 24,765.16. Okay, so the problem's actually finished, but on a deeper scale. If you invested $5,000 at 8% compounded continuously for 20 years, this would be the new balance. That's what it means. Okay, same thing for 37, only to give you a negative for R. So this would be a case where the amount decreases as time goes by. So for instance, the stock market might be going up and down. As you know, sometimes it goes up, sometimes it goes down. Suppose it went down by 2%. All right, so I plug in, you start off with 15,895. Let's pretend again that's money. But you go down 2% for 16 years. What's the new amount? So I plug everything in. Principal is 15,895. E to the negative 2% is 0.02 times 16. Punch it in the machine. 11,542.14. Notice your answer is smaller than the original in this instance because the rate was negative, which kind of makes sense. Over here, your answer went up because the rate was positive. All right, then for a few set of problems here, I need to show you that anytime you see ln e to the x, that's the same as x, and e raised to the ln x is also x. That's because e to the x and ln x are inverse functions of each other. You might recall that we did inverse functions a while back. And so that means anytime you do a function and you immediately do its inverse, like this, f of f inverse of x, you get x, and also f inverse of f of x is equal to x. So whenever you do an ln and an e back to back, they cancel out and you're left with just the x, or it can be written like this, e to the ln x is also equal to x. So what that means for problem 41, ln of e to the fifth. Now you don't need a calculator for that. The ln and e just simply cancel out and you get 5. Although if you did do this on a calculator, you would see it does come out to be 5. And 45 and 49 are just variations of that. ln of 1 over e, the trick for that is to write it as e to the negative 1. We might recall 1 over e means e to the negative 1. And now this looks like that, where the ln and e can just cancel out. So you have negative 1. Likewise for 49, the trick is to make it look like this. ln of cube root of e squared. I'm going to write it as ln of e to the 2/3. You might recall that when you have a fractional exponent, this is the power and this is the root. The power is 2, the root is 3. And now again, the ln and e can cancel out, so you just have 2/3. 53, 55, 59 is just getting practice on your calculator for ln, so just experiment on your calculator. I mean, I can't do it any better than you, but once again, you're going to be using your ln button. Okay, so on my calculator, the ln button is right here. So you just simply hit ln of 35.15 and whatever you get, and they tell you to round off to a certain place. So 3.5596, round it to 4 digits to the right of decimal point, is what I'm getting here. I'm not sure you can see that, but I typed in ln 35.15, 3.5596. So if you couldn't see that, that's okay. You just type it in. Recall, some of your calculators you have to hit it backwards. So if you try this, it's not working, then hit 35.15 and then the ln, and maybe that would work. So just experiment on your own calculator and make sure it works. And a couple more, ln of 0.00465. Just literally type that in, and it comes out to be a negative number this time, negative 5.3709, and that's that one. The third one's a little bit interesting, ln of negative 0.1. If you try to do an ln of a negative number, you should get some kind of error message. It's undefined. So on my calculator, it says error, math, or something like that. But in any event, it should show you some kind of an error message because you cannot take the log of a negative number. So that's why we say that this answer is undefined. So ln of negative 0.1. If you were given something like that on a quiz or test, just put undefined. Then finally, some problems in 61, 65, 67, where they give you the original problem. Ignore this right now. The original problem says ln x equals 1.4023. The way to get rid of an ln is with an e, so I can take advantage of this. The location of the e is a little bit funny, though. So yes, you're doing the same thing to both sides. You're exponentiating. Sometimes students like to say just e, but the proper word is exponentiate. The e goes down and sunken to the left, so in green. So the original problem, again, is what I have in blue. In green is what you do to both sides. You put an e here and an e here. That way this e and ln can cancel out, like here. So x is equal to e to the 1.4023. Okay, and then you punch that in your calculator. So e to the 1.4023, on most calculators, that's a second function. So above the ln, you have e to the x. So you have to hit second function, e to the x, and then 1.4023. And they want us to round to 4 digits of the divided decimal point, 4.0645. Now you have to do the second function. You're not taking the ln of this. It's e to that. So on most calculators, e is above the ln. So it's the second function. So second function, e to the x, and then hit 1.4023, 4.0645. Once again, some of your calculators, you have to go backwards. You might have to hit the 1.4023 first, and then second function, e to the x. So just experiment until you get the answer that you want. Here's 65. The original problem is ln x equals negative 3.71. So to get rid of the ln x, you need to put an e. So you exponentiate both sides. You put an e, but it goes down and to the left. See how it's sunken down a little bit. So now this looks like that. They cancel out. X is e to the negative 3.71. Punch out on your calculator, 0.0245. Make sure you can do this on your calculator. If you're not sure, ask, send me an email so we can try to figure out how your calculator works. Okay. Again, for e, most calculators, it's a second function. So if you want ln, you hit this button directly. If you want e to the x, it's normally above it. I know you probably can't see it on my calculator, but almost all calculators, ln and e, are paired with each other. You have to hit the second function and then e to the x, and then do whatever number they want you to do. Finally, 67. The original problem was ln x equals 1.001. Again, you exponentiate both sides by putting an e. That way the e and the ln can cancel out, like over here. So x is e to the 1.001. And punch it in your calculator. This time we get 2.7210. Okay, and a reminder, so e, its approximate value is 2.71828. If you want to see that on your calculator, if you have an E button, just hit the E button. My calculator doesn't have the E button, so you can trick the calculator by saying e to the first power. So if you hit e to the first power, you should get that. See if I can demonstrate that on my calculator now, e to the 1. Okay, so I don't know if you can see that, but e to the 1, I've had e to the first power, 2.718281828, something like that, for e to the first power. If you can't see it, that's okay. Experiment on your calculator with e to the 1. Again, remember, you might have to hit 1 and then e to the x. All right, so these are notes for Melham's Math 60, Tuesday, April the 28th, section 9.5, page 810.